Thanks for coming. I'm Jason. This is both my first conference talk and my first time out of the Americas, so it should be fun. This is what I do. I'm a production engineering lead at Shopify in Canada, in Ottawa. It's a lovely place, you should go. That means, the lead part means I manage both systems and humans. Today I'm going to be spending a little bit of time on the intersection of those two things, specifically talking about speed and failure. So first thing, how fast can the humans go without blowing up the systems too often? That's the first question I'm going to attempt to answer for you today, and give you some tools to try and answer it for yourselves. In order to get an answer to this, we'll start with the Romans. This is Augustus, who is the first Roman emperor. Wikipedia tells me that one of his favorite expressions is a bit of Greek that I can't read or pronounce. But translated into Latin, it goes festina lente, probably mispronouncing that as well. But in English, and I think I can pronounce that, it means make haste slowly. So it sounds a little bit paradoxical, and when I first read it, I didn't really quite understand it, but the more I spent time with it and looking at what this actually meant, the more it seemed like a really nice way to phrase and to kind of frame the work that we do in production engineering at Shopify. It's also a really nice way to frame kind of the iteration speed of different teams and different systems. So I can't really say it any better than the Wikipedia page, so I'm just going to read the bit of quote here. Activities should be performed with a proper balance of urgency and diligence. If tasks are overly rushed, mistakes are made and good long-term results are not achieved. So the key for our purposes today is the part in red, if tasks are overly rushed. So we know from experience that iteration speed wins in the marketplace, right? The business wants to go as fast as it can in order to grow and sell more products, make more money, etc. Of course, they'd also love to avoid mistakes because mistakes cost money and cost time. And they certainly want good long-term results because they want to be around for a long time. So this idea basically comes down to go as fast as you can, but no faster. Make haste slowly. So how do you do that? How do you figure out when you're going fast enough, but not too fast? One of the ways you do that is by examining your cost of failure. So the definition of what's too fast for you or your team or your system really depends on your cost of failure. So how diligent you need to be to prevent disaster dictates how fast you can go. The worse the disaster, the slower you go. Now there's kind of an obvious difference in scope between a tattoo spelling error and failure to launch a missile. And it's kind of the same with the software and systems that we work on, right? So failure of certain things is not really acceptable, but not a disaster either, right? Most things that fail are pretty much harmless. Failure of other things can completely kill your business. So then there are lots of things, of course, in between those two extremes, and that's usually where we spend the bulk of our time. So let's look at a way of quantifying that cost of failure. One of the ways to do this is to build something which I'm calling a disaster matrix here. So you can either build that within an application or across multiple applications. So I've got 3 columns here in the diagram. I've picked database as the system under question, just because they're fun when they fail. And then down that column are several different disasters that could affect a database, right? An accidental table drop, dropping all the permissions, writer failure, backup corruptions. All really fun stuff. And then you've got 2 other columns, impact and likelihood. Impact being, if that happens, what shape are your systems and your business in, right? Is your availability affected? Is your disaster recovery affected? You know, what gets compromised? And then likelihood is fairly self-explanatory. How often does it happen? Is it a once a decade kind of thing? Is it a once a week kind of thing? You notice the first diagram had a fair bit of red and yellow, and this one has a little bit more green. So what you're trying to do is basically go from red to yellow to green. Sorry. The more green that exists in the diagram, the faster you can go, because you've reduced the impact of failures, you've reduced the likelihood that they're going to happen. If failures aren't that big a deal, then you can move your system a heck of a lot faster than if every failure is a huge ordeal to get through. And one of the great things that this kind of allows you to do is to track it over time, right? So if you've got something like this with history, it becomes a really powerful tool for a couple of things. One is prioritizing what you do next, right? You're looking for the red to see if you can drive that down. And it's also a really great way to look at what you're doing now as well as what your teams have done in the past and kind of celebrate it, right? Some of those cells are awfully hard to go from red to yellow to green to change it colors. And looking back on that, 3 months, 6 months, a year after you've done the work is a very nice way of promoting work that is often hidden. So the work that you do to change those colors are, it's basically what you're trying to do is turn something that is highly visible, like a disaster, into something that never happens, right? And human psychology is such that we're not very good at noticing the absence of things. So it's a great way to highlight and spotlight work that people do that is intentional and important, but often gets missed. So a slight twist on this is basically a matrix that slices it up by a particular property that you want your application or your system to have. So here's an availability matrix, which shows the effect of different systems being down on different sections of an application. So I work for Shopify. We provide online stores. And these three sections are three sections of our application. Storefront is what people interact with to browse products and buy them. Admin is what our merchants, who are the ones who pay us money, use to upload products, change descriptions, fulfill orders. And API is the stuff that robots use to automate some things, build some scripts, build apps for our app store, that kind of thing. And down the left-hand column, you've got different systems. These are all technologies that we use at Shopify and that I have been responsible for at one point or another. And basically what you do is you go down the list and say, okay, if MySQL is down, how does that affect these sections of the application? If Redis is down, how does that affect these sections of the application? The nice thing about this kind of a matrix is you can reinforce it with tests, right? You can build this using code, and then as your reds go to yellow and yellows go to green, you've got some code that's executing all the time to make sure that you're not regressing as you get better, right? For this kind of thing, we use a tool called ToxiProxy, which is something that we've open sourced. It allows you to write code that looks like this. You can simulate a system being down, a system being slow or having really high latency, a system that is responding but sending you back errors just to make sure that the rest of the application deals with that, a system that's responding with valid but incorrect data. So if you're expecting a payload back as a number, it can send you back a string, see how that happens. I won't go into it too much. A colleague of mine, Jake, has a whole presentation on ToxiProxy tomorrow morning, I believe. So if you want to get some more details on that, I recommend attending it. So once you've got all this data on the state of your systems and their cost of failure, you have a framework in which you can look at your speed, right? So you're either going too slow, too fast, or just right. There's really only 3 ways of slicing this. So when you're moving too slowly, not enough haste in your in your planning. So this is basically characterized by features taking too long to develop and ship, long estimation and planning cycles, excessive refactoring, bike shedding, quests for perfection. Generally at this point, if you feel like your team is headed this way or is in this quagmire, it's basically time to sit down with them and talk about what can you do to remove any barriers to increasing the iteration speed. The business at this point gets frustrated with your team, gets annoyed by them, right? Because you're an obstacle, you're not enabling anything. You're moving so slowly that other people either have to go around you or assign work to other teams in order to just avoid the roadblock, right? You're a bottleneck in the organization. The opposite problem is to go too fast, so not enough diligence in what you're doing. The symptoms here are frequent outages, technical debt piling up, lots of working and reworking the same features. You know, oh, it's not quite ready yet, I just got to tweak this and tweak that and tweak this. And alert fatigue if you're on the other end of a pager. It starts off looking great because you're moving quickly, but it really becomes a situation which demoralizes a team really fast. If it goes on long enough, again, the organization and the other teams will start to try and work around you, either technically by using other technologies so that it's not in your sphere of influence, or organizationally, right, by trying to get other, again, it depends on the size of your organization, but in larger organizations, you can work around teams that are not behaving in the way that you think is quite rational. Ideally, you end up in the green zone, the festina lente zone. You can trademark that and stuff. So the feeling there when you're in the green zone is basically sustainable pace, right? So your team can probably keep up this iteration speed forever, maybe not forever, but for a long time. Work's moving through steadily, the systems are getting more resilient, outages are reducing in frequency and impact. Like, you're still going to have bad days because things fail, but usually it's more of an annoyance than a disaster, and hopefully those bad days become fewer and more far between. So in the previous 3 slides, I had a dot, right, which represented where the team or the system was on the scale. So how do you know where in that spectrum you are? So the 2 different kinds of matrices is a nice piece of input to try and figure that out. You can also use things like error budgets and outage reports to help you figure it out. I'm not going to go into those because I don't really have the time to do that. But basically the gist of it is use data and measure these things. Like, you can figure out where you are on this continuum if you have enough data to sort it out. And since I'm a manager, there's also qualitative things that you can do, right? Like, talk to your team members and figure out how they feel the speed of the team is. Even better, talk to other teams that have systems that rely on yours and see what kind of level of service you're giving them, right? See how they feel about how your systems and how your team is performing. So, second question, the systems are gonna blow up, right? When they do blow up, how do you deal with the humans? A lot of SREs deal with applications and systems where the cost of failure is incredibly high. So at Shopify, our production engineering team deals with systems every day where we could cause the company to lose money, suffer brand damage, reputation damage, erode customer trust, and in some cases potentially kill the business outright. So all of this puts a lot of strain on people. So how do you ensure that the humans can cope with these failures without breaking? One concrete way to do it is to give teams as much direct control over the sources of major stress as possible. So if you're going to get paged about a system, and you're going to have to deal with it when it misbehaves, the people who get paged should have a say in the design and use of that system. They should also have control over the configuration of the alerting system. So a source of constant stress that is out of your control is basically a great recipe for disengagement and burnout. If you know what a phantom page is, and you're familiar and you're nodding along at that turn, like that's an early signal that you're on this road. At Shopify, all of our production engineering teams and a lot of our product teams are responsible for their own alerting and monitoring. So we have some standard technologies we use across the board, but it's basically up to the teams to decide what's important enough to wake us up at 2 a.m. versus what can wait till the next day. I can tell you that having experienced this level of control, I never want to work without it, not as an SRE anyway. It just has too many long-term benefits in terms of fostering ownership and responsibility. The screenshot here is a bunch of Datadog alerts, which is one of the tools we use to monitor our systems for the team I'm currently leading. So you can see a bunch of Elasticsearch checks, some Kafka. There's a little Zookeeper in there as well. Another important attribute to foster is the idea that not only is failure going to happen, it's okay that it does, even if it's something that you did that caused it. You have to create an environment where I was wrong or I made a mistake is a perfectly fine thing to say and has no organizational repercussions. So this screenshot, I hope you can read it. Simon is leads another of our production engineering teams, and this is from Slack. So he's thanking a couple of the engineers that work on his team for some work that they did, where we're at the point where we could fail over part of Shopify from one data center to the other using a chat ops command, which is pretty impressive given that 2 years ago it basically took kind of a NASA mission control room kind of thing to do that. So he types out this great paragraph, that's awesome, thanks guys. Types in the command spy failover Shopify pod 1 to chai 2, and then ship it, which is the tool that's actually doing it in the background, returns a 409, which was fantastic. What I didn't show, and I didn't have room to show in the screenshot, was all the all the responses from people just like putting up GIFs and laughing, and just like, it was a really great kind of culture builder moment because everybody was like, yeah, of course it's gonna fail when you try and demo it in front of like the entire company, right? And so it was totally okay, right, that did this. And the reason it failed is because just before posting this, he'd tried it and had been like, great, it's working. But of course it put a lock on because you don't want to fail too often back and forth. So the lock was still active when that happened. Yeah, that was fun. One of the ways that we encourage, this kind of comfort with failure and comfort with admitting failure is doing root cause analysis. So this isn't a new technique, but one of the things we insist on at Shopify is to do blameless root cause analysis. So when a production incident occurs and after it gets fixed, we get the people involved together and we examine the failure. The focus, of course, is on preventing it from happening again, not on whose fault it is. And the reason for that is because it's always the system's fault. Different inputs from the system would have resulted in a different decision. So the system gave poor inputs, person made what might have been at the time a totally rational decision, which ended up with a poor outcome. If you can fix the inputs, you can fix the decision-making process, you can fix the system. The idea is to admit that, of course, failures are going to happen, but you only really care about repeated failures, right? Unique failures get dealt with, get fixed, and then you move on to whatever the next unique failure is. If you see the same pattern occurring over and over and over again, you're doing something wrong in your incident response in that you're allowing these things to creep back into the system all the time. So in summary, first question was, how fast can the humans go without blowing up the systems too often? And the answer to that, or my answer to that, is only as fast as their cost of failure lets them. So know and measure your cost of failure, drive it down over time, it'll make everything go faster. Second question was, when the systems do blow up, how do you deal with the humans? And the answer to that is by giving them a sense of control and safety. So saying, I made a mistake, I was wrong, that should be something that happens very frequently. And it should have basically zero stigma to the speaker. In fact, It should be the opposite, right? They should be thanked for opening a door towards better systems and healthier teams. You can't learn if you can't admit that something failed. Just watch a kid trying to ride a bike. You learn that over and over again. My kids are learning to ride bikes at the moment. And that pretty much concludes my talk. These are all the other talks from all the other lovely Shopify engineers. So just 6 more, I think. We're kind of invading your country and conference, but that's okay. They're all lovely people. You should go talk to them, and you should ask lots of questions. The talk I mentioned about Toxi-Proxy is that Thursday morning one with Jake, so 9:50 to 10:20. But you should go to all of them. They're great. And that is the end of my talk.